differentiation is about the changes of a variable with respect to the changes of another variable. Generally, the differentiation is the process of determining the instantaneous changes happen to a given variable at a particular moment. The rate of change of x with respect to y is denoted as dy dx. The general expression of the derivative of a function is f prime x equal dy dx, where y equal to fx is any function. Related rates. The goal is to find an unknown rate of change by relating it to other variables whose values and whose rates of change at time are known or can be found. Next, apply maximums and minimum problems. The process of finding maximum or minimum values is called optimization. Other than that, Rolle's theorem and mean value theorem. It states that for any continuous differentiable function with two equal values at two discrete points, the function must have a point where the first derivative is 0. Analysis of function 1, there is 2, which is inverse of increasing and decreasing functions, and concavity and inflection points. Analysis of functions 2, relative maxima and minima, critical points, first and second derivative tests, and graph of polynomial and rational functions.
Problems involving the maximum value and minimum value can be solved by using this following step. The first one is by recognizing the main function, which is area and volume, that needs to be formed and derived based on the information given in the problem. This main function can be easily recognized through the word maximum or minimum stated in the problem. The second one is by using let f prime x or dy over dx equal to 0 to obtain the value of the variable which causes the function to be maximum or minimum. The third one is by using second derivative method to find the nature of the value, either it is a maximum value or minimum value. If second derivative is over 0, then it is a minimum value, while if second derivative is less than 0, then it is a maximum value.
So we move to the problem statement. A factory plans to produce a closed cuboid shaped box of height h cm and the length s is twice its width at centimeter is to be made for a volume of 72 centimeter per cubic. So the first one is we must show that the surface area of the box is 4x squared plus 260 per x. Second, find values of x and h that minimize the total surface area of the box. Hence, find the minimum surface of the box. And last but not least, find the minimum production cost that can be obtained in the production of a box if the production cost of the box is estimated to be 50 cents per centimeter squared.
Let's answer the first question. First, we draw a box and label each part for height, width which is x and length which is 2x since it is twice its width. From the analysis of the problem, the production cost depends on the total surface area of the box produced. Therefore, A is equal to total surface area. To make it simpler, we will find the total area for the surface that faces each other since both will have the same value. You can refer to the 3-box drawing on the slide for a better understanding. So, the first area for the two first surfaces is 2x times x multiplied with 2. The second one is xh times 2. And the third one is 2x times h multiplied with 2. Then, we will total up all of these three areas and we will get A is equal to 4x squared plus 2xh plus 4xh. After that, we will need to find the value of height with the volume of the box given, which is 72. First, we have to write down the formula of the volume. It will be length times width times height equal to 72. The equation will be 2x times x times h equal to 72. 2x times x equal to 2x squared. We will move it on the right side and it will be height equal to 72 over 2x squared. the answer will be h equal to 36 over x squared. After that, we have to substitute the value of height, which is 36 over x squared, into a. Then the equation will be a equal to 4x squared plus 2x times 36 over x squared plus 4x times 36 over x squared. It will be a equal to 4x squared plus 72 over x plus 144 over x. The final answer will be a equal to 4x squared plus 216 over x.
Question number 2, we want to find the x and h value. First, to find the x value, we must differentiate the total surface area, which is 4x squared plus 216 over x. So, dA over dx is equal to 8x minus 216x power of negative 2. Next, we let the derivative dA over dx equal to 0. So, 8x minus 216 over x power of 2 is equal to 0. Now we can find the value of x by moving negative 216 over x power of 2 to the right and let the x to the left side. Thus, the value of x is 3 centimeters. After that, to find the value of y, we must find the second derivative by differentiate the first derivative. So we got 8 plus 432 over x cubed. Since we already got the x value, substitute the x value, which is 3, into the second derivative. From this second derivative test, we got 24 more than 0. So x equals to 3 is a minimum value. Now we can find the value of h by substitute the x value. We got h equal to 36 over 3 squared. Thus the value of h is 4 centimeters.
Now we have to find the minimum area with the minimum value, which is x equal to 3. The equation will be minimum area equal to 4x squared plus 216 over x equal to 4 times 3 squared plus 216 over 3. The final answer will be 108 centimeters squared.
Question number 4. The minimum total surface area 108 centimeters square multiplied with Rm 50 cents. Thus, the minimum production cost a box produced is 60 ringgit and 20 cents.
In conclusion, we have to make sure to use the right formula and follow each step properly to find the first and second derivatives. As a result, we will get a correct value for the minimum production cost a box produced.